Welcome back, guys. This is question 6.9 and the statement of this question is given the normally distributed variable x with mean 18 and standard deviation 2.5, find a probability that x is less than 15. Okay, so let me first solve them and let me solve part A first. Okay, so here we want to find out the probability that x is less than 15. So first of all, this is basically the value of x and we need to convert it to z to find out the probability by using the z distribution table. So therefore we know that z is equal to x minus mu divided by sigma, where mu is the mean and sigma is the standard deviation. So let me put all these values. X is 15, mu is what? Mu is 18 divided by the sigma, which is 2.5. so it is 15 minus 18 is minus 3 by 2.5. okay, so let me have it here. So 3 divided by 2.5, it is 1.2. so this is minus 1.2. so therefore in terms of z, we now have to find out the probability that x is less than minus 1.2. so let me do what? Let me use the z distribution table. So in this z distribution table, minus 1.2 is where? Okay, so let me go to minus 1.2. so here it is. This is minus 1.2 and in column we have 0. so this is what? This is what we wanted to find out. So 0.1150. so the answer is 0.1150. that is the solution of part A of my question. Now in part B, the value of k such that probability that x is less than k is 0.2236. so here we have this one. so the probability that x is less than k, this is 0.2236. so first of all, let me find out the corresponding value of z for this value. So for that, we have to do what? If you want to find out the value of z, we have to take the inverse of 0.2236, and this is from the table that we need to find out this value, and then we will write the value of z which corresponds with this value. So let us move to the table as well. So 0.226, we have to look for it here. 0.226. so this is what? This is the 0.2236 and this is for a minus 0.7, and the column it has is this one. This is the 0.6 column, so it would be minus 0.76. okay, so let me write it here. So the value of z for it is 0.76, but it is negative. Let me see that. Yes, this is minus 0.76. so the value of z is known. Now in order to find the value of x from it, we know this formula. okay, and from it, if you want to find the value of x from the z, it would be what? It would be mu plus z multiplied by sigma. so let me put these value. Mu is 18, okay, plus z8 minus 0.76 and the value of sigma is 2.5. okay, let me have it. so it would be 18 minus 2.5 multiplied by 0.76, so it would be 1.9. okay, so minus 18, so this is 16.9, and that is the value of x which we wanted to find out, and that is the solution of part B of my question. In part C, we have to find the value of k such that p is greater than k, and for this value, and here we need to find out the value of z for it, and for it we need to find it by the probability that x is greater than k, this would be 1 minus probability that x is less than k, because this is the value, this is the item for which the table has been created. Okay, so therefore we need to find it in terms of this one. So therefore it is what we know this value. So therefore the probability that x is less than k, it would be 1 minus the probability that x is greater than k, writing it this value. So it is 0.1814. okay, once you will find this value, you will have to process it again by this formulation. You have to find the value of z, and after finding the value of z, you have to use the same procedure which we have done for part B of our question. Okay, so that is part C. In part D, you have to find the probability that x is greater than 17 and less than 21. So let me move down somehow. Here this is part D, and here we have to find the probability that x is greater than 17 and less than 21. We need to find it out in terms of the probability that x is greater than z1 and less than z2. okay, these are the two values of z. So in order to find the value of z1, we have here x1 minus mu divided by sigma, and here this is z2, this is x2 minus mu divided by sigma. This is what, let me use this color, this is x1, this is x2. okay, you have to put it here, you have to put this one here. okay, let me solve it. So solving it, what would I get? Here it would be z1 is 17 minus mu is what? Mu is 18. okay, divided by 2.5, which is the value of sigma. Here it is also given, and in the question it is also given here as well. okay, so similarly for z2, we will have here 21 minus 18 divided by 2.5. it is minus 1 over 2.5. this is z1. For z2, we have 3 over 2.5. okay, so 3 over 25, let me calculate it. Here we have, so 1 over 2.5, this is 0.4. z1 is minus 0.4 and z2 is 3 over 2.5. so 3 over 2.5, this is 1.2. so 1.2. so therefore we need to find out the probability that x is greater than minus 0.4 and less than 1.2. so which is what? Which is basically the probability that x is less than 1.2, and from it we have to subtract the value that x is less than minus 0.4. okay, these two values are where we have to look for them in the z distribution table, because this is z, so therefore we have to utilize the z distribution table for probability that x is less than 1.2. let me have it here. so for 1.2, this is here. okay, so this is now 0.8849. so 0.885. okay, minus probability that x is less than minus 0.4. so minus 0.4 is, this is the minus 0.4, and this is the corresponding value 0.3358. so 0.336. okay, let me subtract it from it. so subtracting it, 0.885 minus 0.336, this is 0.549, 0.549, and that is what? that is basically the solution of part D of my question. okay, so that's it for today, in which we have seen the solution of question 6.9. if you have any question, you can ask me in the comment box. See you soon.